Hi everyone, welcome back to my channel. Today I will teach you about the atmosphere and electromagnetic radiations. You all knew that how remote sensing works. Basically, here you can see a sun is emitting the electromagnetic radiations and then these radiations are striking various surfaces on the earth and then these surfaces emit the radiation back here to the sensor. But between these comes is the atmosphere. So in remote sensing, both the atmosphere and electromagnetic radiations are fundamental because sensors don't directly see objects. They detect the energy that has interacted with the Earth's surface and travel through the atmosphere. So the Earth's atmosphere play a very important role. If we talk about remote sensing, we talk about the electromagnetic radiations and how they are interacting various surfaces on the Earth and then this radiation is reflected back to the sensor. Here you can see the electromagnetic spectrum. Remote sensing relies on the electromagnetic radiations that travels as waves and carries energies. The sensors that we use in remote sensing detect this energy as I already mentioned. This energy is reflected or emitted by the Earth's surface across various different wavelengths. Here you can see the various different wavelengths. The electromagnetic spectrum includes gamma rays, X-rays, UV, visible, etc. Mostly the remote sensing uses visible, near infrared, thermal infrared and microwave part of the electromagnetic spectrum. So this is basically the electromagnetic spectrum. You can see these are the different parts of electromagnetic spectrum and each part of the electromagnetic spectrum reveal different Earth surface features. Satellite sensors are engineered for specific bands to maximize information about land, vegetation, water and atmosphere. When the sun emits the electromagnetic radiations are either scattered, absorbed, transmitted or reflected. These are the four different phenomena that happens before these electromagnetic radiations reaches the sensor, reaches the satellite that we are using for our purpose. Now I will explain it to you one by one what will be happen in these interactions. This is very important topic. We will start with the scattering. Scattering is the important atmospheric interaction. The sun is, here you can see in this diagram, the sun is emitting the radiations and then these radiation will strike the various surfaces present on the earth. Before striking the surfaces on the earth, the radiation will interact with the atmosphere and the atmosphere consists of different particles. When the radiations interact with the particles present in the atmosphere and the radiation is redirected from its direction, this phenomena is called scattering. Basically, the scattering is the incident radiations are redirected by the molecules or the particles present in the atmosphere and these radiations are not absorbed but these radiations are scattered. Now the second atmospheric interaction is the absorption. Absorption is another key atmospheric process that affects how electromagnetic energy travels from the sun to the earth and then to the sensor. What is absorption? Absorption is basically a process. Here you can see in the diagram. This is the incident radiation. There are different gases present in the atmosphere. These gases absorb the incident radiations at specific wavelength, converting energy to the heat. And the key observer are water, carbon dioxide, ozone, etc. Why absorption matter in remote sensing? Why we are studying this? Because it reduces, as I already told you, that it removes the energy from the signal. So it reduces the amount of energy reaching the Earth's surface. It weakens the signal received by the sensors. Now the third atmospheric interaction is the transmission. First, I will tell you briefly about the transmission. Transmission basically means the electromagnetic radiations passes through the atmosphere without being absorbed or scattered. The sun is emitting the electromagnetic radiations and these radiations are passing through the atmosphere. This is the atmosphere. These radiations are passing through the atmosphere without being absorbed. These radiations are neither absorbed nor scattered. But these radiations are passing through a medium. The passage of radiation through a medium without being absorbed, without being scattered, is called the transmission. In transmission, no changes of direction of incident radiation takes place and no energy is lost. Why transmission is important? Transmission is important because if the transmission is high, sensor gets clear data, and if the transmission is low, then the data quality decreases. Now the last and the most important atmospheric interaction is the reflection. What is reflection? Reflection in remote sensing refers to the portion of the incoming electromagnetic radiations that is coming from the sun that strike a surface and is bounced back toward a sensor. Here you can see in the diagram, this is the incidental radiations from the sun and then it strike a surface and then it bounce back to the sensor. This is reflection. The direction of the incident radiation changes and the energy is partially retained. Now you better understand the atmospheric interactions I have explained are the interactions to you one by one. Now let me summarize. There are 4 different types of atmospheric interactions: absorption, scattering, reflection and refraction. In absorption, the energy is absorbed. In scattering, the energy is scattered. In reflection, the energy bounces back. And in refraction, the energy passes through a medium. Hopefully, you understand all of these interactions. If you have any query, then let me know in the comments.